So we're interested in knowing whether or not a series converges. And we're going to look at two quick tools that we could use as ways of determining whether or not a series converges. Now, we're going to develop lots of tools for this. And it's important to know there's no one tool that works every single time. But the first tool that we're going to use is called the test for divergence. It says if you're looking at an infinite series where you're adding up a bunch of terms, if the limit of each individual term that you're adding up is not zero, then there's no way that series can converge. And that's also called divergence. So as an example, we could look at the sum from k equals 1 to infinity of 2k squared plus k over 5k squared plus 7. So we're doing pattern matching here. Our a sub k would be equal to 2k squared plus k over 5k squared plus 7. And let's apply the test for divergence. We look at the limit as k approaches infinity of 2k squared plus k over 5k squared plus 7. And it turns out, if we use L'Hopital's rule, that in a moment, you can see that this limit is equal to 2/5. Now, 2/5 is not zero. And that's the important thing here, is that this limit of the terms that I'm adding up here is not zero. So by applying the test for divergence, it lets me know I can say that this infinite series does not converge. It is divergent. Let's look at another example. This one's kind of silly because I think you can see the answer right away. Let's look at the sum from k equals 1 to infinity of just the number 1. So a sub k is equal to 1 here, and it's obvious that the limit as k approaches infinity of 1 is just 1. It's not changing at all. So this is not zero. So applying the test for divergence tells me that this sum diverges or does not converge. And what's important for me to know here is that I could have known this another way also, because I could look at the sum from k equals 1 to 1 of 1, which is 1, and then I have the sum from k equals 1 to 2 of 1, which is 2, and I have the sum from k equals 1 to 3 of 1, which is 3, and I can tell that this is going to go to infinity and not that this sum, as I increase more terms, does not go to a definite number. So I could also see just by inspection. Now, the test for divergence only goes one way. That's why it's called a test for divergence. And this is really important to point out to you because this is a mistake that people commonly make. You can only use this to prove divergence. You cannot use it to prove convergence. So if we have A and that implies B, doesn't necessarily mean that B implies A. Let's see an example here. Let's just say true or false. Since the limit as n approaches infinity of 1 over n is equal to 0, then the sum from n equals 1 to infinity of 1 over n converges. So take a moment and think. Do you think this is true or false? The answer is false. If this limit were something besides 0, then I could conclude that this does not converge. But just because the limit is 0 doesn't mean I can conclude it converges. So limit as n approaches infinity of a sub n not equal 0 leads you to conclude that the series equals 1 to infinity a sub n diverges. But if the limit of the terms that are being added up is 0, then you can't draw any conclusion.